So I'm Tom Roberts. I'm a senior AI engineer based in London in the Clinical Scientific Computing Department at Guy's and St Thomas NHS Foundation Trust. And we also work very closely as part of the London AI Centre. And so really my role day to day is to sort of make it easier for hospitals to adopt new AI technologies. And part of that is actually making new apps. Part of it is testing existing apps, working with industry, working with universities, kind of joining up all of those different parts. So today I'm going to talk about TotalSegmentator. It sounds like you've had a very brief introduction to this. This is not my own app, as you'll see, but it is publicly available and it's got some really promising results. And what I'm going to use it for today is hopefully to illustrate how you can build a hospital deployable AI app using MONAI Deploy. There we go. So before I go into that, I just wanted to talk about the motivation really. And ultimately, this is a lot of what I do is meeting the demand for medical AI applications. So this is a screen grab from the FDA's website, and it's a long list, a long database of all the FDA approved AI medical devices. And that is software and not software. And currently the count is at 521 devices. And I check into this every now and then, and this number just keeps on going up. And this doesn't even include UKCA or CE mark devices, pieces of software. It doesn't include non-CE mark pieces of software. So there's a huge demand for these AI applications. But the problem that we see really is that you have all of this demand, you have a lot of skills, you have a lot of technology, and there's a lot of investment in all of these different aspects of AI, represented here by industry universities. But once you come to the hospital side, it's very hard because you don't have many technical people, particularly. The policy around all of this is maturing gradually. And really what I'm going to talk about is that there's no real platforms. So this is really challenging. And I kind of sit somewhere in the middle. I work for the hospital, but I'm trying to facilitate this transition from AI coming into the hospitals, bridging the gap. And so this project is motivated by that. And so I'm going to talk a lot about TotalSegmentator. And really, I started looking into this in the period between Christmas and New Year of last year, when I discovered this really and started to put this together and think, how can we use this in our hospital? So on the left, there's a small screenshot, and I'll come on to exactly what this is about. And then I work more broadly on something called AIDE, and AIDE is a enterprise open source software platform for making it easy for hospitals to adopt new AI technologies. And I'm going to talk about this as well. And then joining the two really is MONAI Deploy and MONAI application packages maps. And this is really how you take an app such as TotalSegmentator and you put it into something like AIDE so that clinicians can use it day to day, potentially. So TotalSegmentator itself is a CT imaging AI application. And it is developed by a great team in Basel, the University Hospital Basel. You can see them on the right here, pointing at their results. And what it offers is robust segmentation of 104 different anatomical structures, automatic. And we'll see some of those in the coming slides. And what's just amazing about all of this work is that they've open sourced everything. The AI model, the software, the training data, it's all there. You can download the full 30 gigabyte training data and have a play with it. And I highly encourage you to check out their GitHub. So this is some fantastic work. So what can TotalSegmentator do? This is taken from their GitHub page, but this shows you all of the different regions on CT that are offered by the app. So you've got everything from the bones, the cardiovascular system, including different chambers in the heart, you've got the lungs, liver, the brain, gastro, and also muscles. And really the key point here is that TotalSegmentator has been trained on such a wide array of CT images that it basically works on any CT images that you feed it. And I'm getting to grips with what it can do, and I've passed some data sets through it, and the results have been very promising. But this is really important because you get such a wide array of imaging conditions in the hospital that if you can have a pre-trained network that can just deal with that variability, that's really powerful. It also offers some other extra subtasks as well. I haven't played around with these so much yet, but I'm quite keen to. So it can even do blood vessel analysis in the lungs. It can look at the coronary arteries in the heart. It can give you extremities. It can look at hemorrhage in the brain as well. So there's a lot going on here. And so this is the list of all the regions that it automatically generates. And again, you've got all sorts of things here. Ribs, heart, lungs, all the vertebrae. And as you'll notice, these come out in nifty files, and I'll come back to that in a bit. And then alongside each of those segmentations, you can impart the statistics option, and it will calculate automatically the volume of every single one of those regions. So how can you actually use it? So again, if you go to the GitHub, it's really very straightforward for developers to use. You can simply just install it, start up a Python virtual environment, pip install TotalSegmentator, and you're away. When I tried this, it was great. It was very smooth. I didn't really have any issues. And then to use it in its existing guise is simply just to call the command, feed in your input CT nifty file, and then give it an output directory where your segmentations will be saved. And I've run this on a couple of data sets, and the runtime on our DGX internally was about 2 minutes. Again, it depends on the size of the data set, but it's anywhere between 2 and 5 minutes, really. So that turnaround time is also really valuable as well. But for a clinical environment, we have a problem. This is amazing for developers and for researchers, but clinicians are not going to use it in this form. There is a web app, and again, I encourage you to check that out, but even that is not perfect because it's not linked to all of the clinical systems in the hospital, obviously. So again, this is part of what my role is about. How can we take this and make it more amenable to the clinical users? So that's where AIDE comes in. So I mentioned this at the top. AIDE is a medical AI operating system for the hospital. And this is something we're developing internally in the AI Center, and we've been developing it for a couple of years. I could talk about AIDE for an hour, probably. This is not an AIDE talk, but I just thought I'd give you a quick overview of it. So there's a schematic on the right here, and you've got your clinical users down here, and then you've got app developers here. And these two different parties interact with AIDE slightly differently. So effectively, the app developers will deploy their apps on the AIDE App Store, which is then accessible by using computers or tablets or different devices to the clinical users. Once that app has been deployed on AIDE, the clinical users can send data from their PACS system or their scanner system to the AIDE orchestrator, depending on what apps they've deployed. And the AIDE orchestrator is software and hardware that sits at the center of the hospital or even in the cloud, and it takes that data and it processes it, and then it passes back the AI results. And there's something called clinical review, which enables the clinical users to actually review the AI results as well. And so that data comes back to the clinical users and they can use that. And at the heart of all of this is MONAI Deploy. So again, I encourage you to check out AIDE if you want some more information on this GitHub here. And just so that you can kind of get a feel for what it actually looks like visually, this is a little peek at that AIDE clinical review interface that I showed you. So the doctors would have access to this at their hospital site. And in this case, this is unrelated to TotalSegmentator, but this is actually a stroke app, and it's looking at the level of hemorrhage inside the brain. And if the doctor was happy with the AI performance here, they could press accept, and that data set would then go into the PACS system for clinical reporting. So going back to radiotherapy and TotalSegmentator though, why is TotalSegmentator itself actually important for hospitals? So if you're a patient and you come in and you're scanned, your CT images might look like something like this. And at this stage, the doctor comes in and they will perform manual contouring of the different regions that they are interested in. So in this case, we've got the lungs and we've got the heart. And again, CT is used for all aspects of the body. And this manual contouring process can take anywhere from 0.5 to 4+ hours, depending on which regions you have to segment. And then after that, you've also got dosimetrists who might even do additional contouring. And basically, it's a lot of time spent performing these manual tasks. They are semi-automated in some pieces of software, but it's not instantaneous. Those contours are then used to actually optimize the radiotherapy dose that the patient receives. So in this case, you've got a lung nodule here, and you can see the beams from the radiotherapy coming in and irradiating maximally inside the actual tumor. So it's important for these contours to be very accurate because they are used to optimize these radiotherapy doses. And once that's done, the planning is done, the patient then goes back on the treatment table and then undergoes their course of treatment. So really what I'm getting at is we want to, the low-hanging fruit here is just to attack here and try and reduce the burden of manual contouring. So that's why we're personally excited about TotalSegmentator. So, as I say, I've been working on this for probably less than a month, and I've been using some data sets external to TotalSegmentator itself just to test its capability. So this is a data set from the MONAI Deploy Express repo, and you can see that the lung nodules, the lung nodes here are really nicely segmented. Similarly, in the heart, these are the regions that it offers in the heart. So you can see the myocardium, the left ventricle, left atria. You can also see the aorta. And again, this is doing a really good job of data that it's never seen before. And then this is a local hospital data set. And again, it's done a really nice job in the heart and the lungs. And you can also see the 3D visualization of all of the different contours that it happens to have segmented in this region. So again, we're really excited by these preliminary results. I've shown it to our internal hospital teams, and again, they're getting quite excited as well. So we need to make this accessible for them. So that's where MONAI Deploy comes in. So we're going to make a map, and then this is easy to deploy on AIDE. And off the back of that, there's a potential that we can start to roll this out to 10 other NHS trusts which are involved in the AIDE program. And so to do this, I've created a map, MONAI application package, which you can find here on this GitHub repo. And basically what this does is that it has 3 different modules, if you like. These are operators. I'm sure you're going to find out a lot more about this in the rest of the talk. And so the DICOM images, the CT images come in. I've constructed an operator to convert those DICOMs to NIfTI files. Those NIfTI files are then fed into TotalSegmentator, which then performs the segmentation. Those segmentations come out in NIfTI format, and I need them back into DICOM format. So therefore, I'm using a Python package called RTUtils, which converts from NIfTI into a DICOM RT struct format, which is what the CT scanners like. And then these are fed out of the map and go back into the scanners or packs or Eclipse. So I'll briefly go through this. This is AIDE. At the heart of AIDE, or a little schematic of AIDE, at the heart of AIDE is MONAI Deploy. These are the different components in MONAI Deploy. So from the clinical information systems, the data is sent to MONAI Deploy. The first one it hits is the informatics gateway, which decides what data is it that I'm seeing. The data is then passed to the workflow manager, which then in turn passes the data onto the correct app that you're running on AIDE. So AIDE might have multiple different apps. And you can see here that I've got TotalSegmentator. If it determines that that's the correct data set, then it will feed it back to the clinical information systems and back to the clinician. And this is all automated. The clinicians, all they have to do is select the data and send it to AIDE, and it does its thing. And it comes back to them with the AI results in 2 to 5 minutes. So just to recap, TotalSegmentator was not made for MONAI or AIDE. And this is amazing because, you know, this is something that we've picked up, and we can then fold it into AIDE using MONAI Deploy. And that's exciting because then we can hopefully start to roll those out across different healthcare systems. And TotalSegmentator itself has the potential to greatly enhance and potentially speed up clinical workflows. And that's just the sort of first idea we have for this. We could potentially use this for looking at pathologies, looking at interesting new things in research. There's all manner of different potential applications here. And I would encourage you to look at TotalSegmentator itself as well, because it is a really great toy model to learn about medical AI. Again, it's all open source. You can see the networks, you can see the data, and then you can see how we've linked this into MONAI Deploy as well. So I hope that makes sense. I hope you learn a lot in the coming talks as well. Thanks very much.
Great, thanks, Tom. There's two questions, one kind of related question to each other, and then another one. So I'll kind of merge two of these together. So someone asked about FDA approval. So they asked, FDA approval also works for commercialization in the UK, and whether every new app to AIDE has to be FDA approved, and what is that process to get an app onto AIDE?
No, so they don't have to be. So AIDE will work with FDA, UKCA, and apps that are not approved in that way. AIDE is going to be rolled out in the next 3 to 6 months across the different trusts, and then the process for getting apps onto it will be to effectively, in the short term, submit them to us for approval, and then agreements, if it's not FDA approved, agreements will need to be put in place, licensing between the hospitals and the app developers so that they can be run at the different hospitals.
Cool. Let's see, there's a few more came in, but this next one is, do you need to fine-tune TotalSegmentator to particular tumor segmentation so it can identify lesions? Or is TotalSegmentator only segments normally functioning, does it only segment normally functioning organs?
Yeah, good question. So at the moment, it's just segmenting the regions that I've shown you. There are some subtasks, and I hinted at that one, which was looking at hemorrhaging, but I don't, to my knowledge at the moment, think there's one specifically for tumors. But again, what you could do is potentially retrain it. If you've got labeled tumor data, say, I don't know, long nodule data or something like that, they've provided the networks, you could retrain it and potentially get those segmentations out.
Cool. Someone asked for the GitHub link, and David put that in chat. So the GSCT CSC repo for the TotalSegmentator piece. There's also just the TotalSegmentator repo itself. So I'll put that one in chat here in a moment as well. Yeah, I think you had it linked somewhere in here.
Yeah, there's quite a few in here.
Yeah, that one there.
Yeah.
Let's see, is there a way to choose the required segmentations of TotalSegmentator?
Sorry, Michael, say that once more.
This one says, is there a way to choose the required segmentations on TotalSegmentator?
So TotalSegmentator by default will just attempt to provide all 104 anatomical structures, but say your field of view is focused on the chest region, and obviously the head's not in that region, so therefore it can't provide the segmentation. It will just provide effectively an empty nifty file. What you can do is, again, and what I was planning to do with the maps is effectively have a check to see which ones have been contoured, and then we can tailor depending on what the application is. So if you're only interested in lungs, for instance, it only produces the contours for those. It's very easy to turn them off, basically, and select what you want.
Got it. Okay. One more in here that was more, I'll leave this other one for last, but do you get approval per hospital for AIDE, or can you run it at any hospital in the trust?
So again, that will depend on UKCA marking. At the moment, it's going to be per trust, but you'll be able to install it on AIDE, and then if those trusts opt into using, then it'll be all of the technology will be in place for those hospitals to then go ahead and start using their products, or those apps rather.
Got it. Okay. Another one just came in. Have you run into any specific data management provenance requirements from the hospitals or regulatory boards?
Is this a kind of technical question with DICOMs, or? Can you say it once more? I
No.
can't see the chat myself, Michael.
Oh, yeah.
Out. So in terms of, I haven't really run into any problems on the input side so far. DCM to NEX, if we're talking technically, is really robust at converting DICOMs into NIFTs. In terms
So they
of
mentioned about traceability of the data. Yeah.
Yeah. So have you run into any problems with what? So I mean, more broadly, if this is a question about AIDE, so AIDE keeps logs of every single payload that is passed through it. So it logs the time, it logs what app was run, it logs whether there is a success or a fail. And again, that is all to do with data management and making sure that it's clinically safe and having an audit trail as well.
Yeah. And there was another one here of, is AIDE easily deployable in any hospital? Does it require a license?
So AIDE will be open source at the moment. If you go to the repo, we're gradually making available AIDE effectively. So at the moment, I don't think you'll be able to go on there and actually deploy it at your hospital yet, but that is incoming. You will be able to run it on pretty much on any computer, but obviously if you've got very GPU intensive applications, then you'll need to factor that in basically. It can be run on hardware. We run it on DGX, which each of our partner trusts are running, but you can also run it on a cloud instance as well. That's an option.
Cool. And I don't know, do we have a deadline or sort of an estimated time when we think it's going to be fully open sourced? Is there any estimate right now?
I would say next 3 to 6 months. That's
okay.
the timeline.
Cool. I think those are mostly everything. The last one, David actually answered about Kapana. And so I think those were all the Q&A. Thanks, Tom. I think that was great. And there was a lot of good questions afterward as well. So
yeah,
thank you
great.
for that.
Yeah, thanks for the questions, everyone.